Hello, in this video I'm going to start a topic. I'm going to make a series of videos on this topic of trig graphs. So when you're talking about trig graphs, you're talking about sine and the cosine and the tan graphs. Okay, now before going into circular trig, let us start with a triangular trig. So let us draw a right angle triangle. Say this is your right angle triangle. Okay, so this is a right angle triangle. So what do we know in right angle trig? Okay, say if this is the angle, say theta, if this is the angle theta, this is the opposite side, and this is the adjacent side, and this is the hypotenuse. Okay, now we are going to do slightly change the notation. We're going to say this is, say, x, and this is y. Okay, you can understand why, because this is across, so it's horizontal. So I'm going to take instead of saying adjacent, I'm going to say this is x and this is y, and this is, say, r. Okay, or that is radius or the radial length, because we'll move from here to circular trigonometry. So this is x is adjacent, y is your opposite, and hypotenuse is your r. So what do we know? So we know sine theta is opposite over hypotenuse, so that is same as y over r. Okay. What else do we know? Cos theta is adjacent over hypotenuse, which is x over r, and tan theta is opposite over adjacent. So we are not doing anything new. This is right angle trig that you already know, that is y over x. Okay, now one more thing, a new thing that you probably not be knowing is tan theta is same as sine theta over cos theta. Okay, now how did I get that? Sine theta, what is sine theta? Sine theta is y over r divided by x over r, which is y over r divided by x over r, which is y over r times r over x, which is nothing but, so tan theta is y over x. So this is a new formula which can be useful. Tan is sine over cos. Okay, there's one more formula which is useful. So can I say, I'll do an identity, probably may be useful in other places. It's good to know one identity. So that's a very, very important trig identity. It's nothing but Pythagoras theorem. Okay, so it sounds to be great, but I'll show you. So can I say, using Pythagoras in this triangle, can I say y squared plus x squared, or x squared plus y squared is equal to r squared? Okay, so what I'm going to do, I'm going to divide this by r squared, this by r squared, and this by r squared. So this becomes y over x the whole squared plus x over r the whole squared is equal to 1. Now what is y over x? Oh, y over r, sorry, not y over x. So y over r. What is y over r? Y over r is sine theta. So I'll change color. So this becomes, oh, I'll delete, okay, I'll do the working, yeah. Okay, so this becomes y over r is sine theta, which is sine theta squared plus cos or cosine theta squared is equal to 1. And in trigonometry or in algebra, we write sine theta squared as this. We don't write sine squared theta squared, we write sine squared theta plus cos squared theta is equal to 1. This is a very important identity. Probably we'll use that later. Okay, so these are something that you already know, nothing great. Now this is called a unit circle. This is called a unit circle. Now, unit circle is the foundation of circular trig. Okay, so now this I can call this is the right angle trig. This is called the right angle trig, and this is called the circular trig. I call this the circular trigonometry. This is the extension of this. Okay, so now this is a unit circle of radius. Why do we call this a unit circle? This is a circle with radius 1 unit. It can be any unit. It can be centimeters, meter, or kilometer. It doesn't matter. It's a unit circle of radius 1. Okay, so those who have learned circle, equation of a circle, the equation of this circle, though it's not important, just to relate one topic with the other, the equation of this circle is x squared plus y squared is equal to 1. Okay, so as this is a unit circle with radius 1, I hope you understand this is 1 comma 0, this is minus 1 comma 0, this is 0 comma 1 and 0 comma negative 1. Now you are thinking, when you're talking about circular trig, you're thinking in terms of a point which is rotating around this circle. So you're taking an arbitrary point P which has the coordinate of x comma y, and this is, say, I will say I need to change that to theta, so let me change that to theta. Okay, so this distance, suppose this is P and so this is O and this is A, suppose. Okay, so in triangle OAP, angle OAP is a right angle. So where do I have the space? Okay, I'll try to fit in here. So let me change color. Okay, so can I say cos theta is opposite over hypotenuse, that is y over 1, which implies y is nothing but cos theta. Okay, and can I say sin theta? Sin theta is what upon, oh, I made the mistake, sorry, cos theta, sorry, I should have not made this mistake. So cos is adjacent over hypotenuse. The adjacent of theta is x, so it is x over r, and the radius is, sorry, x over r, and the radius is 1, so that's 1. Or it's adjacent over hypotenuse, the hypotenuse is 1, so I can say x is equal to cos theta. Okay, sorry for this mistake. This is not acceptable as a maths teacher. Okay, so sin theta is opposite over hypotenuse. Your opposite is y, and the hypotenuse is 1. So you can say y is equal to sin theta. So now your coordinates, which is x comma y, has been changed into a trig form. So I can say this point x comma y is nothing but cos theta comma sin theta. Okay, so you should understand this. So the whole coordinate system can be changed into a trig form. So x is nothing but cos theta and y is sin theta. Okay, so let me do a little more. What can we do? Okay, now when you're talking about, so if x is cos theta and y is sin theta, x is, you can say x is sin theta. So sin, when theta is 0, the point is at, say, this point, this here. Okay, so let me name this point. Suppose this is say, what can we say? So this is A, so let me say this is B, this is C, this is D, and this is E. Okay, so when you're saying theta is 0, you're saying the point is at B. Okay, so let me show that. Let me write that. So when theta is equal to 0 implies point, PT point, is at B, okay, on the unit circle. So what did we say? X is cos theta and y is sin theta. So x would be cos 0, cos 0. X is cos 0 and y is sin 0. So now sin 0. So what is x and y at B? This is your x at B and this is your y at B. So we just said, now you can write, but at B, can I say x is 1 and y is 0? Therefore, can I say, if I say x is cos 0 and then again I say x is 1, can I say cos 0 is 1 and sin 0 is 0. So what does this mean? Cos 0 means when the particle, suppose by convention, when you're talking about degrees, is always anti-clockwise from this point. Okay, so it's always anti-clockwise from B. Okay, so this point is the starting point. Oh, sorry, I should have done the arrow like this. Now let me remove that. So this is, by convention, this is B is the starting point. So at 0, when theta is 0, the point is at B, and your x is 1 and your y is 1. So you can say, that's why on a calculator, cos 0, if you press on a calculator, let me show you, get your calculators out. So let me bring this here. So menu, run, and let me set this in degrees. First, you should set this in degrees first. Okay. So when you go, it doesn't matter, degrees or radian doesn't matter. Cos 0, if you type in cos 0, it will give you 1. So what is it telling me? That at 0 degrees, your x coordinate is 1. Or in other words, at 0 degrees, the point is 1 away from the y-axis. I'll not go into those details. And if you do sin 0 is 0. Okay, that is your your y is corresponds to sin theta and x corresponds to cos theta. So at 0 degrees, the y coordinate, which corresponds to sine, is 0, because at point B, your x coordinate is 1 and your y coordinate is 0. I'll continue this in the next video.